Okay, so find any stationary points. So part 1, I find y dash, which is 4x squared minus 12x squared. Okay, with this question too, I'm going to find, there's going to be horizontal points of inflection, and then we're also going to find the inflections that are in between the stationary points. So y dash equals 0, so you've got 4x cubed minus 12x squared equals 0. So it's 4x squared x minus 3 equals 0. So 4x squared equals 0, x squared equals 0, so x is 0, and x is equal to 3. So when x equals 0, the y value would be 0, 4 minus 4 times 0 squared, which is 0. So you have 1.00, and when x equals 3, it's 3 to the 4 minus 4 times 3 cubed. So that's, I'm just going to do it like this, I don't need a calculator. It's minus 27. So it's 3 minus 27. Okay, now we're just going to determine their nature. So we have 0, 0, and we have 3 minus 27. Now we know that y dash is 4x cubed minus 12x squared. Y double dash is 12x squared minus 24x. So I can determine the nature in two ways. If I used y double dash, that would be your table of values. So you put 0, 3, and then you just got to get a point either side. Let's go minus 1, 1, and 4. You're putting it into y dash, so it's important that you write that on top. I also think it is better if you actually factorise it so you can see the sign. So if you put minus 1 in there, the first part is always going to be a positive because of the square. And that's going to be times a negative, so that's a negative. 4 times 1 squared, 1 minus 3, that will be a negative. And then when you put 4 times 4, 4 minus 3, that will be a positive. So what's actually happening here is we go negative, 0, negative, and then we go positive. So we have a horizontal inflection, and then we have a minimum point. So that means this is a horizontal point of inflection, and this one here is a minimum turning point. So the other way that you can do this is using y double dash. So y double dash will equal 12x squared minus 24x. So if I like to take the 12x out, and what would that be? X minus 2. Okay, so if we put in x equals 3, we get y double dash is 12 times 3, 3 minus 2, which would be a positive. So it's 36. Therefore, x equals 3 is a minimum. That's how you use the y double dash. When you put in x equals 0, the y double dash is 12 times 0, 0 minus 2, which is 0. This is an indication that it is a possible horizontal point of inflection. So it's not good just to accept that it is. You then have to check y double dash changes sign, because what you're actually checking for there is a change in concavity. Okay, so we go like this, we go x, y double dash equals 12x, x minus 2. So that's going to be 0, go 1 minus 1, 0. So if you put in minus 1, y double dash equals 12 times minus 1, minus 1 minus 2, which is a positive, because it's a negative times a negative. It's a positive. If you put in 1, y double dash equals 12 times 1 times 1 minus 2, that would be minus 12. So it's a negative. So therefore y double dash changes sign. So it's a change in concavity. And if you think about it, you got 0, 0. That one there means it is concave up. So this side's going to be up, and the other one means it is concave down. So it's going to look like that. So that's the direction it's going to be going in. So we have two things. We have 0, 0, 0, 0, 0, which is a hurry inflection. And we have 3 minus 27, which is a minimum turning point. The next part was to find any points of inflection. So this means the other points of inflection. And there'd be one between these 2 points because you have 2 stationary points. So y double dash equals 12x, x minus 2. So step 1 is to make y double dash equal to 0, solve for x. So 12x, x minus 2 equals 0, 12x is 0, x equals 2, x equals 0. This one here we've already found. This one is our hurry inflection from the previous question. It is also a stat point. This one here must be the 1. See how that's a 0 and a 3? It's a 2. So that must be the one that is in between the 2 stat points, the hurry and the minimum. Okay, so if you've got x equals 2, you then need to find the y value. So you go 2 to the 4 minus 4 times 2 cubed, which is 16 minus 4 times 8, which is minus 16. So it's 2 minus 16. And then the other thing you need to do is check that y double dash changes sign. Because whenever you do an inflection, you're going to have to add in an additional table to check that it changes sign. The only time you don't need to do this is when you find the horizontal point of inflection and you're using y dash. If you use y double dash, you're always going to have to do it. So always put what you're subbing it into on top. So if we look back, y double dash was 12x, x minus 2. And if you go either side of that point, if you put in x equals 1, y double dash is 12 times 1, 1 minus 2, minus 12, which is negative. And this one's y double dash is 12 times 3, 3 minus 2. So that's 36, which is positive. So therefore y double dash changes sign. Therefore it will be an inflection. And just notice it goes from negative, which is concave down, to positive, which is concave up. So we now have 0, 0, 2 minus 16, and 3 minus 27. This one's a horizontal point of inflection. This one is just the inflection in between the 2 stat points, but it's not a stat point. And this one here is a minimum local, so a local minimum. You also need to get the y-intercept. So it's x4 minus 4x cubed. If you put x equals 0, you get 0, 4 minus 4 times 0 cubed. So you end up with 0. So it's the same as that point there. Alright, so now all we've got to do is just do the third part, which is to sketch it. We've got 0, 0, 1, 2. Now I'm not going to worry about the scale on this. I'm going to go minus 5, minus... So I'm just going to give myself a little bit more room because it seems to be very loaded down in the negatives. Minus 5, minus 10, minus 15, minus 20, minus 25, minus 30. So we go 0, 0, 1, 2, go down to minus 16, 3, go down to minus 27. So 3 minus 27, 2 minus 16, and so you draw that first. Nope, that's not correct because that one was the horizontal point of inflection. So it goes concave up, concave down. This one's a minimum, so it's concave up, and then you keep going like that. Now I know this one didn't say to find the X-intercepts, but they really aren't that hard to find. So if you make y equals 0 and you factorise it, you get x equals 0 and x equals 4. So you know that this curve comes back up here through 4. I'll just fix that up a bit. So there it is there. So if it's really simple to find, just fine.